Hey, MathKook here. This video contains one of many examples in my Algebra 2 library. The rest of those examples, along with hundreds of other videos, are only available at mathkook.com. Let's MathKook it up. This question says, use Gauss-Jordan elimination to solve the system of equations. So here we have a 3 by 3 system of equations with 3 equations and 3 variables. So let's take a look and see what Gauss-Jordan elimination is. So Gauss-Jordan elimination is the same as Gaussian elimination, except you must go further and put the matrix in reduced row echelon form to solve. So when in reduced row echelon form, the solution is on the right of the vertical line. So here's an example of a matrix in reduced row echelon form. So notice the first row has 1, 0, 0, and then there's zeros below the 1. The next row has a 1 to the right of the 1 above it, and then the third row also has a 1 to the right of the 1 above it. And notice below each of these 1s here and above it are also zeros. So it takes more work to get into reduced row echelon form, but it's worth it because your solution is clearly seen on the right. Here's your x, your y, and your z value. So 2, negative 7, 1 would be the solution for this particular matrix. All right, so let's go ahead and apply this to our problem here. Now, I've already done the work in example 3 of this lesson for putting this system of equations into row echelon form. So if you'd like to learn how to put this matrix in row echelon form, please see example 3. So here's the result of example 3 right here. So this matrix is this system of equations transformed to row echelon form. In this problem, we're going to transform this into reduced row echelon form. All right, so let's get started. So it's nice that there's zeros here and 0 here, and then every single line starts with a 1, which is great. So next, to put it in reduced row echelon form, we want this negative 1 to be a 0. So I'm going to go ahead and underline that. So we're kind of moving left to right here. If either of these numbers was not 0, we'd have to transform these to zeros. So let's go ahead and change this to 0. Now this works out pretty nicely because if we just add row 2 and row 3 here, these two guys will cancel out. So we're going to go R2, I'll say R2 plus R1. And we're going to rewrite R1 because, again, we want this to be a 0. Okay, so let's go ahead and rewrite R1 here. So 0, we're going to add R2 plus R1. So 0 plus 1 will give us 1. So I'll write that over here. And then 1 plus negative 1 here gives us 0. And again, that was the whole point of doing this step. Negative 3/5 plus 1 will give us positive 2/5. And then negative 18/5 plus 8, if we do that, that will give us, we need a common denominator. So this would be, if you times the 8 by 40, or sorry, by 5 over 5, you'll get 40 over 5 minus 18 over 5, which gives you 22 over 5. So we'll write that over here. So unfortunately, we were kind of doing some fractions early on here, but that's just kind of the nature of this problem. All right, and then the row 2 and row 3, we're just going to rewrite those guys. So we have 0, 1, negative 3/5, and then negative 18/5. And then we have 0, 0, 1, and then 1. All right, so here's our new matrix. So next we want this to be a 0, and sorry, these two guys to be zeros here, and then it'll be in reduced row echelon form. See how there's zeros here? So we want the negative 3/5 and the 2/5 to both be zeros. We have to do 2 steps here. So what should we multiply? And we have to use the bottom row to make these guys zeros. So what should we multiply the bottom row by to make the top row here a 0? So we need to multiply by negative 2/5. So negative 2/5 times R3 plus R1, and we're going to rewrite R1. What should we multiply the third row here by so that this will cancel out with the negative 3/5? Well, hopefully you said 3/5. So 3/5 times R3 plus R2. All right, so let's go ahead and do the work here. Let's start off with the negative 2/5 times R3. So negative 2/5 times 0 plus 1 will just give us 1. So put a 1 here. And then we have negative 2/5 times 0, which is 0, plus 0 is 0. Negative 2/5 times 1, which is negative 2/5, plus 2/5 gives us 0. And again, that was the whole point why we did this step here. And then negative 2/5 times 1, which is negative 2/5, plus 22/5 will give us 20/5, which is 4. So that works out really nicely. So this is a 4. All right, next we'll do this step here. 3/5 times 0 is 0, plus 0 is 0. 3/5 times 0 is 0, plus 1 is 1. And then 3/5 times 1 is 3/5 minus 3/5 is 0. And again, that was why we did that step, to get this guy to be a 0. 3/5 times 1 is 3/5 minus 18/5, which gives us negative 15/5, which is, if you simplify that, negative 15/5 is negative 3. All right. And then lastly, we just rewrite our third row here. So 0, 0, 1, and then 1. All right, so this is fantastic. Now our matrix is in reduced row echelon form. As you can see, all the ones going across and everything else is a 0. So that tells us that this is our x value, this is our y value, and this here, 1, is our z value. So our answer is 4, negative 3, 1. So this is the point where all three of these lines in a 3 dimensions would intersect. 4, negative 3, and 1. Hey Kook, if you found this video helpful, hit that like button, subscribe, and drop a comment. For unlimited access to all of my Algebra 2 videos, visit mathkook.com. Thanks for watching.